We're gonna move on to the next application, which is a difference amplifier. So again, this is something which is very widely used in electronics industry, especially when you have two sensors and you're trying to find the difference between the two sensors, or whenever there is a difference between two sensors, it triggers a signal. That's where difference amplifier comes in. Okay, so again, you know, it's very common that sometimes we may want the difference between two signals. Okay, all right. Now, one thing that we learned on Thursday of a differential amplifier, right? Differential amplifier. Is this a differential amplifier here, folks? If yes, then how? Anybody recall differential amplifier? So differential amplifier is an amplifier where you have both terminals of the op-amps. In this case, I have both the negative terminal and the positive terminal. You have a power source connected to it. Not the power source, the input signal, sorry. So those would be referred to as a differential amplifier, where the two input terminals of the op-amp, the negative one, the positive one, negative one is the inverting terminal, the positive one is the non-inverting terminal. They are connected to a input signal, AC source. Now, if you look at the negative terminal here, you have a V out going, there's a feedback R2. And then if you look at the positive terminal, VP, it's not directly connected to the ground. There is a voltage divider configuration over here at this point, right? Okay. So again, we're gonna go by our basics and try to find out some of the parameters here. So I'm gonna have to ask you here. We know that VP is equals to VN, correct? VP we know can also be written as V plus, VN can also be written as V negative, okay? Can you guys tell me what is this VP over here? Can you give me an expression for that? What is going to be VP here? Just apply what here? Can we apply voltage divider here?
Yes.
Because VP, the wire that's going into the positive terminal of the op-amp and R2, they are connected in parallel. So whatever the voltage is across R2, same voltage will be at VP, correct? So what would that equation be for that?
VP times R2 over R1 plus R2.
VP times what?
R1 over R1 plus R2. Sorry, VP times R2 over R1 plus R2. Sorry about that.
Yes, correct. So V2, that's the total, that's your input signal coming in. V2 times R2 divided by R1 plus R2. Okay, that's good. Perfect. That's a good start. Okay, now we're gonna apply the same thing. Now we're gonna apply that KCL, and I'm gonna apply KCL at, again, this node right here, okay, at the negative terminal of the op-amp. Okay, remember you got this V out here, right? You have some current IF going into this node. You also have some current flowing going past resistor R1, and of course you got IN going into the negative terminal. So give me an equation. So say this white dot right here represents node A. What is the KCL equation that I'll get?
Oh, it'd be I1 plus IF minus I, wait,
Mhm.
minus in equals 0.
Okay. Correct. Correct. So you said I1 plus IF equals to IN, right? And because we know this is going to be 0, so I can just write it down I1 plus IF equals to 0, correct? Right? Now, can you guys tell me I1 in terms of the V over R, what would that be?
Of V1 minus Vn over R1.
V1 minus Vn over R1. Perfect. What about IF?
V out minus Vn over R2.
Minus Vn over R2. That is absolutely perfect. Just right here. And this is equals to 0. Again, I have to solve for V out here from this equation, right? So I have to rearrange it such V out minus Vn over R2 equals to minus V1 minus Vn over R1, correct? If I take multiply R2, take it over there, then I get V out equals to negative V1 minus Vn over R1 times R2, correct? And then from here, actually over here on this part right here, I have V out minus Vn equals to, yeah. And then from here, maybe I'll just go here. V out equals to minus V1 minus Vn over R1 times R2 plus Vn, correct? V out equals to, now do we know the value of Vn here?
Yes, it's the same as VP.
Which is this thing right here. Correct? Right?
Yeah.
Okay, I'm going to replace Vn with that equation that I have over here, equation A. So this will turn out to be a big equation. And if I can simplify that, it's going to be Vn, and then I have R1 plus R2 divided by R1 minus V1 dot R2 over R1. And this will be V2. Again, this Vn comes from here, V2 times R2 over R1 plus R2 here. This R1 plus R2 remains here, divided by R1, and then minus V1 dot R2, R1 remains as it is here. Now here I can cancel out this right here, R1 plus R2 and R1 plus R2 cancel out here. I will have R2 over R1 dot V2 minus R2 over R1 dot V1. That is my V out. I can further simplify this. If I take R2 and R1 common here, then I will have V2 minus V1 over here And once I have this equation, if I am only interested in getting a difference of the two input signal, I don't want to magnify it. What can I do to this equation right here?
Make R1 and R2 equal.
Yes, right, absolutely. If you are not interested in the gain, you want to get the difference. Then if here we have, if R2 is equals to R1, which basically means this right here, these values needs to be same. All these four values needs to be same. If that is the case, then V out will just simply be R2 over, say, because R1 is R2, so I can put R2 here, V2 minus V1. This and this will cancel out. So V out is just simply V2 minus V1. Right? Okay. If let's say, I want you to focus on these equations right here. There is a limitation. Now, not every circuit is going to be a perfect circuit, and not every circuit is going to be the only circuit in a circuit. It could be a combination of different kinds of amplifier. Difference amplifier may just, go with a voltage follower, or can just add to a instrumentation amplifier to make a complete circuit, depending upon what we are trying to achieve. My question over here, with this circuit, with these equations and the circuit that we have, if I need to magnify one input signal, can I do that with this and keep the other input signal as it is and then take a difference? If you notice here, this V2 is one input signal and this V1 is one input signal. Okay, is it a way for me in this circuit, the way we have set it up, to magnify this and then take a difference?
No.
No, that is correct. But how? Why?
I believe it's because they're multiplied by the same thing, R2 over R1, so you can't really separate them.
That is because, absolutely, that is because we are R2 equals to R1. Remember, the reason we got VP equals to, sorry, here, right here, VP equals to VN, and from this equation, and we were able to pull this equation over here, replace that. That happened only because R1 and R2 were same. We got this V2 minus V1 only because R2 and R1 were same. If we don't have that, we will not get this equation right here. So that is one of the limitations here. But maybe we don't need it, most people just would simply go with it, and they are only interested in the difference. And when they don't want to magnify the difference, they just make sure that R2 and R1 are always same, which we kept over here as well. Okay.